In our first weird connection, we looked at how a duck's quack hides its own echo. Now we'll meet an animal who's a master at using the echo to map its surroundings.
We want to get inside the bat's head as much as we can, but of course we have to use indirect measures. We can't ask the bat, "What did you think? How did you experience that?"
Dr. Cynthia Moss is a psychologist with some unusual patients. She runs a bat lab at the University of Maryland, documenting the amazing echolocation skills of the American fruit bat.
Personally, I've been interested in questions of perception for years and years. And I do think that there are analogies between the bat's use of echolocation for perceiving its surroundings and our use of vision.
Using high-frequency sounds to navigate the environment and find food, a colony of bats can devour 250 tons of insects a night.
Just the fact that the bat so very quickly can maneuver through dense vegetation, avoid hitting trees, and still catch its bugs. It must have a really rich display of the world using echolocation.
It turns out that with their highly tuned senses, bats produce a detailed audio picture of the world, detecting shape, size, and texture.
The bat's sonar vocalizations are used for its perception of the world. So it provides us with a little bit of a window to its perception because we see that it changes its sounds in response to objects in the environment.
Professor Moss translated bat echoes into a graphic computer program. Its cone-shaped pattern represents the sound, starting from the bat's mouth and spreading out over the environment.
This is an animation of the beam pattern of the bat's vocalization. You can think of it like an auditory flashlight.
The echoes bounce back from solid objects into the large bat ears. Each ear picks up specific and slightly different sound characteristics. The differences help the bat construct a complex sonic image of the surrounding world.
The beam pattern and the directional control gives us some insight to the bat's attention to the world, where it's looking, if you will.
Now Dr. Moss was ready to discover just how detailed a picture a bat can perceive through echo navigation.
Well, we have an obstacle course for the bats, and there are two openings in this very fine net. Maybe you can see the outline of the opening here, and there's a similar opening on the other side. And the bat has to find the opening that houses a worm.
It will require a series of intricate moves that can only be accomplished if the bat picks up precise information about the maze.
If the bat flies through that hole, in this case, the compartment doesn't have any food in it, so the bat goes hungry. But if it flies through this opening, this compartment houses the worm and it gets a food reward.
Infrared cameras film the bat's flight, and microphones on the walls record exactly when and where it lets out its ultrasonic calls. Finally, Dr. Moss picked out a plump and juicy-looking worm and baited the compartment. She released a very hungry bat. It wasted little time adjusting its calls to find a way through the obstacles. The bat flew through the complex maze and grabbed the worm without trouble. Watch the 3D software as it documents the bat's path, slowed down by a factor of 10.
So you'll see as the bat flies towards the net, it's changing the direction of the beam. And that really means it's changing the direction of its head. It's pointing in different directions to sample information from different locations.
Professor Moss even went further in exploring just how precise the bat's sense of detection was. She had conditioned it to prefer smooth surfaces over rough ones. Then she hung up two tiny beads, one rough, one smooth. Would the bat be able to tell the difference?
So now the bat's making sounds in the general direction of the two beads. pointing towards the textured bead. Now it's shifted to the smooth bead, and again, it got it.
Mother Nature's gift to bats, echolocation, can outperform all current sonar technology. But there's a theory that humans possess it too, if only we'd listen to our own innate ability deep inside.